Hello and welcome to lesson 8.2. We're going to talk about the characteristics of quadratic functions. So you guys know from lesson 8.1 that the shape of the function, when we see our standard form of an equation y equals x squared plus something x plus something, as in ax squared plus bx plus c, we know that we have the shape of a parabola or a curve opening up or down. Today's objective is to find the zeros of our quadratic function from the graph and find the axis of symmetry and the vertex of a parabola. We have new vocabulary words: the zero of a function, or there could be zeros, it could be plural, and our axis of symmetry. So we are taking notes. Anytime you need to stop and get these notes written down, we need to do that. Everybody's on their own time frame. So recall that an x-intercept of a function is a value of x when y equals 0. A zero of a function is an x value that makes the function equal to 0. So a zero of a function is the same as an x-intercept of a function. This is very important. This needs to go in your notes. These are synonymous. The zero of a function is the x-intercept. Since a graph intercepts the x-axis at the point or points containing an x-intercept, these intersections are also called the zeros of the function. A quadratic function may have 1, 2, or none. So let's look at this function right here. It says finding zeros of a quadratic function from the graph. To find the zeros of the function from its graph, we look at the graph and we know and understand these to be x-intercepts. So we can see that the zeros of this function in standard form are -1 and +3. -1 and +3. So we check. Now we just read that in order for something to be a zero, it makes the equation equal to 0. So we're going to take our first one, -1. We're plugging it in for the x value since it is the x-intercept. -1 squared minus 2 times -1 minus 3, and we can see, check, we do get a 0. We plug the second 0 in, do the math, and we also get a 0. Let's find the zeros of this graph, x squared plus 8x plus 16. Looking at the graph, we can see that we have 1 0. It appears to be at -4. We plug it in, and indeed we do get the value 0. Y equals 0 when x is -4. It has 1. Notice that if the parabola has only 1 0, the 0 is the x-coordinate of the vertex. We talked about the vertex yesterday in lesson 8.1. That is where it changes direction. So in this parabola, we're going upward. We stop here at -2, y equals -2, and start to go downward. That indicates we have a change in direction. It also indicates the vertex. When the parabola has 1 0, that 0 is the x value of the vertex. Now on example 1c, it says find the zeros of this function from its graph and check your answer. Remember, the 0 is the x-intercept. This parabola does not touch the x-axis, and therefore there are no zeros of the function. But we still have the function, and we can still talk about other parts of it. I want you to check it out. Find the zeros of the quadratic function by looking at the graph, and then check your answer. Go ahead and pause and restart when you're done. So looking at check it out 1a, it says this graph does not cross the x-axis, so there are no zeros of the function. In 1b, it says find the 0 from the graph, check your answer. Here's our graph. We can see that we have 1 0. It touches in one point on the x-axis, and that value would be 3. The 0 appears to be 3. We plug it in to check, allowing x to be 3. Do we get y equals 0? Indeed we do. Another one of our vocabulary terms for this lesson is a vertical line dividing a parabola into two symmetrical halves This is known as the axis of symmetry. The axis of symmetry always passes through the vertex of the parabola. It cuts it in half. You can use the zeros to find the axis of symmetry. Here's some notes. Make sure that your pencil's sharpened up. We need all of this in our notes. Finding the axis of symmetry by using zeros. If the function has 1, 0, it uses the x-coordinates of the vertex to find the axis of symmetry. Here we see that our axis of symmetry is at the point 3, 0. It only has 1, 0. That value of x has to be the axis of symmetry. Here's a very important concept. This is the axis of symmetry. It is a vertical line. Therefore, it is in non-standard form. Vertical line is always x equaling something, x equaling that point in which it passes through the axis. X equals 3 is our axis of symmetry. The vertex has 2 coordinates, 3, 0. In this case, it sits at 3, 0. We have 1, 0. In the case where we have 2 zeros, this is very important. Please make sure you're writing this down so that you do understand it. We use the average of the 2 zeros to find our axis of symmetry. Let's look to the graph. We see 1, 0 at 0. We see another 0 at -4. We are going to take the average of those 2 zeros, meaning add them together, divide by the number of zeros, giving us our axis of symmetry, or halfway in between the 2 points. So x equals -2 is our axis of symmetry in this case. Concept is here. If we have 2 zeros, we find their average. That gives us our axis of symmetry. So let's find the axis of symmetry by using zeros. Here is our first parabola. It contains 1, 0. And we know that 0, that x value at that 0, to be our axis of symmetry. So if we look at this, the x-coordinate of the vertex, -1, 0, therefore our axis of symmetry is x equals -1. We're going to use the second concept that we went over just now in our notes. I have 2 zeros in example 2, part B. I have a 0 at 1 and a 0 at 4. I'm going to take those 2 points, 1 and 4, and I'm going to find their average. 1 plus 4 is 5. 5 halves is 2.5. Therefore, my axis of symmetry, cutting this parabola in half, is x equals 2.5. Please come up with the axis of symmetry for each of these parabolas. Pause your recording and come back to see the solutions. So for example 2, check it out, part A, we see 1, 0. So we're going to locate that 0, identify the x-coordinate of it. It is at -3. Therefore, we know that our axis of symmetry is x equals -3, or that x value. Remember, it's a vertical line. It only has x as a variable in its equation. In part B, check it out, example 2, we see 2 zeros. They are at -2 and +4. Since we have 2 zeros, we know we're going to use their average. We take the 2 zeros, -2 plus 4, +2, divided by 2, where it's an average. We find our axis of symmetry at x equals 1, and we can see when we visualize that it does indeed cut our parabola in half. X equals 1 is our axis of symmetry. If a function has no zeros, or they are difficult to identify from the graph, we have a formula for backup to find our axis of symmetry. The formula works for all quadratic functions. So we don't have to look at the graph. We can simply go straight to the formula, and here it is. The quadratic function in standard form, remember our coefficients a and b. The axis of symmetry is the vertical line x equals, we know it always starts with an x equals negative b value, whatever this coefficient is, we take the negative value and divide it by twice a. Here's an example to write down into your notes. If this is our quadratic function in standard form, 2x squared plus 4x plus 5, x, our axis of symmetry, x equals negative b over 2a. I simply substitute the values b and a, so negative 4 over 2, 2 is standard in our equation, times the a value 2. 4 over 4 negative is negative 1. The axis of symmetry of this parabola is x equals negative 1. So we're going to use that formula right now. Finding the axis of symmetry, we're going to take negative 3x squared plus 10x plus 9. Step 1, find the values of a and b. We know that a is negative 3 and b is positive 10. Use the formula. We should always write down our formula so that we can see that we are inputting values correctly. We're going to replace b with 10, a with negative 3, and do our computation. 10 divided by negative 6, and I'm going to take the negative of that. So these two negatives are going to give us a positive quotient. 5 divided by negative 10 simplifies to 5/3. So our axis of symmetry sits at x equals 5/3, or 1 2/3. Not an easy number to depict on the graph, and so that's why our formula comes in very handy. You guys check it out, example 3, and come right back here and we'll go over the solution. So I hope you gave yourself plenty of time to do that. Again, we're going to identify the values a and b. In this equation we see a is 2, b is 1. Remember, no coefficient indicates that we have a 1. We're going to substitute that into our formula, negative b over 2a. Negative 1 over 2 times 2, or negative 1/4, is our axis of symmetry. Once you've found the axis of symmetry, you can use it to identify the vertex. This is good to have in your notes. Which one is easiest to find first? The x-coordinate of the vertex. Find the axis of symmetry by using zeros or the formula. To find the corresponding y-coordinates, substitute that which we just found for the axis of symmetry, the x-coordinate of the vertex, back into the function. This will give us our y value. Write the vertex as an ordered pair. So here's an example of what we are supposed to be doing. In finding the vertex, we're looking for that exact point, the coordinates x and y, that indicate the position of that point where we change from going negative to going positive. So we're going to go through these steps. We're going to find the vertex, find the coordinates, the x-coordinates of the vertex. The zeros are negative 6 and negative 2. So we're going to go ahead and find the average of those, giving us x equals negative 4. The axis of symmetry that cuts this in half is x equals negative 4. In order to find the y value that corresponds to that x value, we simply plug it back into the function. 0.25 times x squared, our new value for x, is the negative 4. Substituting that in, we get a value of negative 1. So the ordered pair, negative 4, which was our axis of symmetry, negative 1, which was our solution when we plugged the x value in, gives us the ordered pair for our vertex. Let's find the vertex of this problem, going through the steps. Finding the x-coordinate of the vertex, identify a and b. We have negative 3 and 6. Now we're using our formula. We're going to find x by substituting b and a into our formula, negative b over 2a. We're going to substitute negative 3 for a and 6 for b. Finding our vertex at 1. We're going to take this x value, 1, plug it back in, giving us our y value of negative 4. Our vertex, the ordered pair, is at 1, negative 4. You guys try this. We'll come right back to the solution. These are the steps for the first part. We found the x-coordinate of the vertex to be 2. Please pause and go over this, and then come right back to look at this. We're substituting the value 2 into our function, giving us a vertex which sits at 2, negative 14. Join me right back here for the second half.